Hello everyone, and welcome to this session about the Data Warehouse Cloud and its embedded business warehouse, the BW Bridge. Let me start by introducing myself, your host for this session. My name is Joachim de Walens. I'm an analytics consultant, mainly focusing on SAP Business Warehouse, SAP HANA, SAP Analytics Cloud, and SAP Data Warehouse Cloud. I'm joined by my colleague Bert.
Hello everyone, also from my side. Welcome to this session on Data Warehouse Cloud and the BW Bridge. My name is Bert Bakelmans. I'm mainly specializing in SAP Business Warehouse, SAP HANA, SAP Analytics Cloud, and Data Warehouse Cloud.
We both work for Cubis Solutions, which is a consultancy firm founded in 2010. Together with our already 65 other colleagues, we have a strong main focus on SAP Analytics. That's how we became an SAP Silver Partner and a Bronze SAP Quality Award winner back in 2016. When I say we focus on analytics, we can divide that into these three grand pillars. Together with our two sister firms, Lytics and Avix, we are specialized in data warehousing, business intelligence, and last but not least, big data and Internet of Things. We offer services like the complete range of analytics projects. From inception to support, we help the customers to implement the best possible analytics solution, with also keeping training and continuous improvements in mind. Now let's have a look at the agenda for this session. First, we will see what Data Warehouse Cloud actually is and what it has to offer. Next up, we will do the same for its BW Bridge. Once we know what both solutions are, we will see how they could fit in your current or to-be SAP landscape. Then Bert will give you a demo on how Data Warehouse Cloud and BW Bridge actually work together. And at the end, I will provide you some key takeaways to remember. First up, what is Data Warehouse Cloud? When talking about Data Warehouse Cloud, we can look at it high level by using 4 key points. It's scalable and flexible. You have the choice between moving data to the cloud by replicating data sets or accessing data remotely, so you can find the right balance between on-premise and cloud deployment. Spaces make it possible to scale individual areas of the data warehouse or data mart independently, rather than having to build huge monolithic systems. They also allow you to create an environment that meets your particular requirements. You can assign users and connections to a specific space and adjust the storage capacity. Spaces are virtual environments with their own databases. They are decoupled, but are open for flexible access, thus allowing your users to collaborate without having to worry about sharing their data. To model your data and create stories, you need to start off by creating a space in your Data Warehouse Cloud tenant. It's a no-code environment and enables business users to work on their own to understand and connect data, transform it into insights, and share the results of their analysis instantly, without coding, delays, manual processes, or data duplication. This environment consists of dedicated virtual workspaces, data modeling and sharing, no-code modeling tools, and pre-built business content. It's made for business and IT. The SAP Data Warehouse Cloud creates a bridge between the needs of IT and the desire for more flexibility of the business department. IT provides qualitative data, while the business department has its own spaces and can, for example, create or edit data models within them. In this way, IT and the business departments can work in different spaces, but within one system. Now I give the word to Bert, who will go more into detail for each of these characteristics.
Thank you, Joachim. To explain what Data Warehouse Cloud is, I will dive deeper in the core functionalities available within the system. So let us focus first on data modeling. Data Warehouse Cloud has 2 modeling layers, each tailored for different user groups. The first modeling layer is the data builder. This is the area where IT users create models based using a technical approach. So connections to data sources can be set up and the data can be prepared and transformed. Whereas on the other side, in the business layer, the business users create their models using a semantic approach. So the business users, they can see facts, measures, and dimensions, which are already modeled in the data layer. And based on that, they can create their own business models in order to answer their own business questions. Now, let's dive deeper in the functionalities of the data builder first, and we kick off with the entity relationship model. So the entity relationship model is really the starting point for all data modeling in Data Warehouse Cloud. Here we can define all elements and entities, and we can define interrelations between the table in the form of a schema. Also, extra information and semantics can be added to the tables in an entity relationship model. Next up is the data flow. In the data flow, we aim to persist data in order to work more efficiently with large volumes of data. So when a data flow is executed, the data is read, it is transformed, and will be persisted into Data Warehouse Cloud. A nice feature here is that Python code can be integrated in data flows in order to be able to perform advanced data transformations. Then the data flow is followed by the graphical view. Here, the focus lies on data federation and virtualization. So in fact, we are connecting to the data. So here, calculations, filters, joins, and unions can be added to the model. And in fact, graphical views can be compared to HANA calculation views, as it provides more or less the same functionalities. So note that a graphical view is virtual, whereas in a data flow, the data will be replicated. Then lastly, in the data builder, we have the SQL views. So basically the SQL views are similar to the graphical views, but with a code-based input. Then the second layer is the business builder. So in the business builder, users can create business entities such as dimensions or analytical data sets. And these entities are based on views which are created in the data layer. Here you also see an example of an analytical data set. Note that the business entities are independent from the data layer and include versioning to allow high-level control. In the next step, a fact model can be created. A fact model is a combination of multiple business entities, including facts and dimensions, as well as added calculations across multiple facts. Then lastly, we have the consumption models, which allow you to combine business entities and fact models to create an output that answers a concrete business question. A consumption model can contain multiple perspectives, and you can enrich business entities with additional calculations if necessary. Once you are done with a consumption model in Data Warehouse Cloud, you can deploy it and access the consumption models in any target visualization client, such as SAP Analytics Cloud or any other third-party business intelligence tool. The last core Data Warehouse Cloud functionality I want to cover is data governance. So when you give data in the hands of people, it's really important to maintain a proper data governance strategy. Data Warehouse Cloud works with the concept of spaces, and spaces can be seen as virtual work areas where users can cooperate on the same data. Each space can represent a line of business or an ad hoc project. So in this example, you see that we have a sales, a marketing, and an HR space. And in each separate space, connections can be set up to sources, developments can be made, and those developments can be shared across multiple spaces. Joachim, I pass the word to you to explain more about Data Warehouse Cloud's landscape.
Thank you, Bert. Now let's have a look at how the Data Warehouse Cloud is actually built. First of all, we have the core, in which the data warehouse is actually split into the spaces. Each space has its own connections, data models, and so on. Of course, users need to be able to get to that core. This is done by using the Cloud UI, via all the available tools of which Bert just explained a few. Last but not least, we have to acquire our data from our data sources, so we have our data sources to connect to. Then we have this blurred out part of the image. This is something Bert will explain later on. When we look at this architecture in a more layered approach, we can divide it into 4 layers. We look at it from bottom to top. Very important, getting the data into Data Warehouse Cloud. This is facilitated by setting up connections to the required sources. This is managed by the IT user or the IPT department. Once the connections are set up and ready, Data Warehouse Cloud users can start with acquiring the data by setting up the well-known extraction, transformation, and loading process. By doing this, useful data can be provided to the business users. For setting up the complete ETL process, we have several tools at our disposal, like the Data and Data Flow Builder, scheduling, monitoring, and so many more. This is managed or used by IT and maybe some more advanced business users. When the data is available in a useful, clean manner, the business users can start creating their own semantically rich analytical models. Again, Bert showed you the tools at our disposal for this. This layer is meant to be used by the business users. As we can see on the right, these three layers are managed per space. So each space has its own connections, models, users, and so on. Of course, once the models are ready, the business users can create their own dashboards or any reports that fit their needs in SAP Analytics Cloud or any other analytics tools. Now I give the word back to Bert.
Thank you, Joachim. So now that we have an idea of what Data Warehouse Cloud has to offer, it might be interesting to talk about the BW bridge in Data Warehouse Cloud, which helps us to mitigate the transition to the cloud. So now, what is the BW bridge? It is a feature in Data Warehouse Cloud which delivers BW for HANA-based functionalities as part of Data Warehouse Cloud. When the BW bridge is set up, a dedicated space is foreseen which runs on an ABAP runtime environment. To mitigate the transition from BW to Data Warehouse Cloud, existing BW models can be reused in Data Warehouse Cloud using the BW bridge, such as info providers, transformations, ABAP routines, and so on. Note that the BW bridge has no OLAP features, so the BW bridge is not intended to be used as a source for reporting. It's only intended to reuse existing BW models in Data Warehouse Cloud or to use advanced BW capabilities in Data Warehouse Cloud. All this information brings us to the next question: how is the BW bridge then integrated in Data Warehouse Cloud? And well, the BW bridge consists of four main objects. First, we have the core, and the core exists of all objects which are created in the BW bridge, such as info providers, transformations, data sources, and so on. Data sources connect directly to source systems via ODP. The core objects are managed using the BW bridge cockpit used for monitoring and managing the BW objects, process chains, and authorizations. The BW bridge cockpit is comparable to the BW for HANA cockpit. Next to the cockpit, all the developments in the BW bridge are performed via Eclipse using the BW modeling tools and the ABAP development tools. And lastly, a dedicated BW bridge space is available in Data Warehouse Cloud, from where we can share our BW bridge developments to other spaces in Data Warehouse Cloud. Now I would like to give the word back to Joachim, who will explain you how Data Warehouse Cloud and the BW bridge could fit into your SAP landscape.
Thank you, Bert. So we can say that SAP's Data Warehouse Cloud is a very nice cloud data warehousing solution, but what with your on-premise SAP systems? Let's have a look at two very possible scenarios. The first scenario is a hybrid scenario. In this scenario, you will use a Data Warehouse Cloud to work with data coming from your on-premise S/4HANA and BW for HANA systems. This can be done in several ways. Let's say you have set up your BW for HANA system, which is collecting data from S/4HANA and probably some other sources. All of your BW modeling is done, future-proof, and the data coming out of it is ready to be used further on by your business users. This can be set up by federating the data from your BW for HANA system to the Data Warehouse Cloud. In this way, your data comes from your BW for HANA system, but business users can do their modeling in the cloud. Parallel to this, Data Warehouse Cloud can also get data in real time from S/4HANA for operational reporting purposes, for example. In the next scenario, the BW bridge comes into play. Let's say you have an S/4HANA system, but you do not have a modern, up-to-date data warehousing solution. You might have a legacy BW system which you might want to carve out, or not have any data warehousing solution at all. In both cases, Data Warehouse Cloud's BW Bridge feature might be just what you need. BW Bridge offers you BW features right inside of Data Warehouse Cloud. Data can be replicated from your S/4HANA system to the BW Bridge, and this will happen via ODP. Once a connection is set up via the Cloud Connector, you have the most important BW features at your disposal. Just like Bert explained, we have info objects, info providers, transformations, and even ABAP. Non-SAP sources, however, will connect directly to the Data Warehouse Cloud itself. Like I just mentioned, it's perfectly possible that you have a legacy BW system which you want to carve out. If you intend to use Data Warehouse Cloud, BW Bridge might be your way to go. To make life easier for you, it's possible to migrate your legacy BW to the BW Bridge. It allows you to transfer your existing models from the legacy BW to the BW Bridge and thus leverage your existing on-premise designs. Your BW Bridge can be set up as a clean or a greenfield installation, but remote and shell conversion are possible as well. For these, your legacy BW needs to be at least at version 7.30. Then you can migrate selected data models via the transfer cockpit. But what does all of this actually look like in practice? Now, Bert will give you a hands-on demo on Data Warehouse Cloud and BW Bridge.
Let's say our organization wants to compare the current sales with the targets which were set for this year. Our sales and business partner information is coming from the organization's S/4HANA system. This data will be replicated into the BW Bridge via ODP CDS. From the BW Bridge space, we will then share our models to the TechEd space, where we can combine our sales data with our sales targets data. Let me show you how this works in practice and switch to Data Warehouse Cloud. Within Data Warehouse Cloud, we can navigate to the space management to take a look to the BW Bridge space. Within Data Warehouse Cloud, you can create one and only one BW Bridge space. When this space is created, a BW system will be generated in Data Warehouse Cloud. Within the BW Bridge space, you can, for example, scale the storage based on your requirements, and also other settings can be applied. In order to maintain and to monitor the BW Bridge, you can go to the BW Bridge cockpit, which you can find back in the Data Integration Monitor. So we'll navigate to the Data Integration Monitor into the BW Bridge cockpit. So when I open the BW Bridge cockpit, you will see that this looks very similar to the BW for HANA cockpit. So process chains can be scheduled, ADSOs and info objects can be maintained, and a lot of other options are available as well. So now, how do we replicate the data from the CDS views into the BW Bridge? Let me switch to HANA Studio. In S/4HANA, we have one CDS view regarding the sales information and another CDS view regarding business partner information. These views are exposed for consumption using the annotations. In the BW Bridge, a new source system is added via ODP, in this case via ODP CDS, in order to be able to consume the CDS views from S/4HANA. So here in S/4HANA you see that we have the BW Bridge, and at the bottom you see that I added our S/4HANA on-premise system as a source. In the next step, an ADSO is created for the sales view and an info object is created for the business partners. Transformations and DTPs are created and the data can be loaded via process chains. Now the data is available within the BW Bridge, but we also want to consume this data in Data Warehouse Cloud and combine it with the local sales target file. So we switch back to Data Warehouse Cloud. In Data Warehouse Cloud, we go to the data builder of the BW Bridge. So here you see that we are in the BW Bridge data builder. Here you can see that I already imported two remote tables from the BW Bridge, which is the sales ADSO and the business partners info object. Now, these tables are only available within the BW bridge space, but yet I also need this information in our TechEd space. So I need to share these tables to this TechEd space. And as you can see, when I click on the sharing icon, you will see that this is already done. So now I can navigate to the data builder of the TechEd space. And here you can see that I already created an entity relationship model, which is a starting point of modeling in Data Warehouse Cloud. So here in the entity relationship model, I defined the interrelations between the tables. I also added some extra semantics and so on. And then in the next step, a graphical view is created. And this is where we combine the actual sales coming from S/4HANA with the local sales targets file. As you can see, I also applied some filter settings and we performed some extra calculations. As a result, we get one output node in the graphical view on which we can base our sales report, which I will show you in SAP Analytics Cloud. So here you can see a nice report which is built on top of the model we created in Data Warehouse Cloud, where we combined our S/4HANA sales data with our local sales targets data.
Thanks for this clear demo, Bert. Now let's conclude this session by going over some of the key points which you can take home. First, the first point is consumption. All our data models are created in Data Warehouse Cloud, and they can easily be visualized and analyzed within SAP Analytics Cloud or any other third-party tools via ODBC. Secondly, there's data modeling. Data can be wrangled and enhanced with logic using entity relationship models, where we can define interrelations between tables, but also graphical views, data flows, or even ABAP-based data modeling by using the BW bridge. Thirdly, data integration. Data Warehouse Cloud seamlessly connects to on-premise and cloud sources, whether they are SAP or not. Fourth, governance. Data Warehouse Cloud works with the concept of spaces. A space resembles a virtual working area where users can collaborate on the same data. Important to know is that row-level security is supported in Data Warehouse Cloud. And last but not least, the BW bridge, which is not mentioned on this last slide. It offers us the most important BW functionalities right inside of Data Warehouse Cloud. Well, this was our introduction to Data Warehouse Cloud and BW Bridge. Thank you all for your attention.